Okay, I want to work through some examples here of how to figure out proofs. This is from 8D, section Roman numeral 3, and I'm going to do number 27 here. Now your basic strategy, pardon me. Alright, this is 8D, Roman numeral 3, number 27, and we're working out proofs here. So we're given these three premises, and our target is to prove S and not Q. Now your basic strategy when you're trying to figure out a proof like this is to start from the end, okay, and think about how do I get this out of all that. So the last line of our proof is going to be that we know that we're heading there. And then your overall strategy is to think, do I see that target, right, S and not Q, is it embedded somehow in the premises? Now I don't see that exact conjunction, but I do see the pieces of it. Okay, so I see here's a not Q here, and I also see here's an S. Now if I could just somehow jailbreak the not Q out of premise 2 here, and if I could jailbreak the S out of premise 3, then I could put them together by using the conjunction rule, and I would have my desired outcome. So actually I'm going to go ahead and write those lines in. I'm going to assume I got an S, and I'm going to assume that I can get a not Q, and then I'm going to assume that I'm going to apply those rules to this line together and to get my final outcome. So I'm going to even put in the rule that I'm going to use. I'm going to apply those to whichever lines these end up being. So then my questions are, how do I get a not Q? Okay, actually not Q, I think I can jailbreak out of here pretty easily, because I can apply the simplification rule to premise 2, and that'll give me not Q, because if it's true that not Q and all this junk, then I can get just not Q. So that's easy. Now my question is, how do I get S out of here? That's going to be a little bit trickier. But I know that if I can get S and M, then I can apply the simplification rule to that, and so lay the next one down, and that'll give me S, right? So now my question is, how do I get S and M? Well, if I could get all this from this part of line 2, and if I could also prove that the antecedent is true, not P or R, then I could apply the modus ponens to those two premises, and I would get S and not M. So guess what my questions are now? How do I get not P or R? There's actually an easy way to do this, because I see not P in here through conjunction, right? Okay, so I can get a not P. Watch this. I will get not P. How did I get it? Because I can just apply the simplification rule to premise 1. So I'm going to 1 simplification. Got it. Now, how do I get not P or R out of just not P? Actually, that's a piece of cake. Because I just apply my addition rule to not P, and that's going to give me not P and R. I'm going to go in and fill in, after I'm all done and I know which numbers these lines end up being, I'll fill in the line numbers as I go. Okay, so now my question is, how do I get this big mess right here? Okay, actually I'm going to move the line order because it'll make it clearer. Clean this up a little bit, don't actually need this. All right. Now my question is, how do I get all this? Well, easy. If I've got line 3, so if I could just prove that the antecedent of line 3 was true, then I can apply modus ponens to line 3 and to this, and that would give me the consequent, all this stuff here. All right, so I'm going to assume that I'll be able to do that. I'll be applying modus ponens to 3 and whatever else this ends up being. So how do I get not P and not Q? Well, actually I've already got both of those. And I could switch the lines if I wanted to. I will, in fact. I've already got not P. I've already got not Q. And so I can just put those together with the conjunction rule. Now I've already got it. Okay, now I've got all the steps in my proof. I'm there. And so what I want to do is give them all the right line numbers. So what I've done here is just to fix the ordering and fill in the line numbers, but that's the final product.